Hey guys, welcome to lecture number 3, Computer Science 401. Yesterday I have lost my voice, but I feel better now, a little bit. Okay, so let's try to, I'll be trying to show you a couple of things in this lecture, and that is the material which you'll be tested on eventually. So remember how I told you that we'll be talking a lot about career, okay, and then something which you will not be tested on the quizzes and on the midterms. Okay, and here's the information which you will be tested on the quizzes and on the midterms and on the final exam. Okay, so programming languages, right? First off, we want to talk about the types of programming languages. What kind of programming languages do we have? Okay, so yeah, types of programming languages. Okay, what kind of categories do we have? Okay, number one, we have functional, functional programming languages. Okay, so what is that about? Functional. Okay, they employ a computational model based on recursive definition of a function. Okay, um, so of course, C, C Sharp, Java, or Python, those languages are not functional. Okay, functional is a completely different like set of like I guess family of languages. For example, a very popular programming language called Clojure, uh, Clojure programming languages. The Clojure, okay, this one. So if you take a look at the code, how it's written, you'll see that it looks completely different from a Java or C or Python. Example. Yeah, something like this. So you see different. Yeah, that's a very good example. Um, and this as well. Okay, so the whole idea, I mean, I can't really understand what it says, but the whole idea is that every single thing there is a function. So even a little variable is also a function. And kind of the way you write code is just you create a function, the only function which is executed, and and then um, like if you want to create a subroutine, that also becomes a function, and every constant also is a function, lambda function, and so on and so forth. It's just a completely different way of thinking, I would say. Okay. Yeah, and like every single time we have parentheses, whatever we have in between is basically the argument to that function, to that new function. Yeah. So anyway, so those are the functional languages. Okay. They take the inspiration from the lambda calculus. Okay. Which is a formal computational model developed by Alonzo Church in the 1930s. Okay. In Java, of course, you also have lambda functions. Okay, so the function which is doesn't have a name. Okay, yeah. So by the way, us talk about that. Um, Example grazia in Java. Okay. Okay. Also, lambda function would be a function which doesn't have. Well, I guess in all the programming languages. Okay. So what do we know about lambda functions? They don't have names. Doesn't have a name, and also it is used immediately when it's declared. Well, because you don't have a name. Okay. Perfect examples. Okay, so examples of functional languages. Okay, Clojure. Okay, Lisp, ML, Pascal. I personally know people who love them. I don't really know. I just don't. I think it's just a completely different world to me how they work. Okay, second one, data flow. So the second type of programming languages, data flow. Okay. Um, so they model computation as the flow of information. Okay, tokens among primitive functional nodes. Okay, so you have tokens and you have nodes. Okay, they provide a naturally parallel model. Nodes are triggered by the arrival of input tokens and can operate concurrently. The best way I can explain that is imagine you have something like this. So I don't know, here are the nodes. Let's say they're located like in this, in some kind of chaotic way. And imagine you have the flow, and the flow is, I don't know, something like this. They go like that, then through this, then here they split, okay, okay, and here they come together again and go somewhere else. Okay, so you have a flow. We have the data tokens coming in, and these nodes have something which they do perform some actions to that data. Okay, for example, methods would be a good example of those uh, nodes. Okay. Okay, so ID and val are examples of such. Okay. What else? Okay, moving on. Next type, logic or constraint. Constraint based languages. Okay, so logic based or constraint based languages take the inspiration from predicate logic. They model computation as an attempt to find values that satisfy certain specific relationship. Okay, using goal directed search through a list of logical rules. Okay, so here's different. Remember how you did like in calculus? Like imagine you have a system of equations. Okay, I don't know, x plus z plus y is equal to 50. Okay, x times x, so x squared plus y squared is equal to, I don't know, 100, okay, and z minus x is equal to also like 70, something like this. No. Okay, so something like this would be a very good like logic constraint based language example. Okay, so because you have a system of logical rules. Okay, so x plus z plus y has to be equal to 50. This has to be equal to 100. This has to be equal to 70. Okay, and the way the compiler works is that they just go through all possible, all possible values of all the variables. Okay, and that's how they so and then once they satisfy all the requirements, they basically stop the execution of the program. Okay. Also very unusual, again, Java, C, and C#, C++, Python are not here yet. Okay, so about those three types of languages, we don't have Java yet. Okay, so that's how they work. Okay. What, like, you have Prolog is a good example. Sometimes you could say that SQL, okay, XLST are examples of such. Okay, moving on. Von Neumann languages. Okay, so that's already something you already know. The most familiar and successful. Okay, they include Fortran, Ada, 83, C. Sorry. Okay, and of course like Java, your favorite Java as well. Okay. Okay, so what are they based on? The core such languages are the variables, values of which are constantly changed. Okay, so again, in our languages, in Java, it's all about variables. You create a variable, you create an object, you change it constantly all the time, and you just use it all the time. You use it, reuse it. That's basically the whole thing. That's the whole idea. Okay. Okay. Whereas functional languages are based on expressions that have values, Von Neumann languages are based on assignments. Okay, so when you say student S1 is equal to new student, right? That's how you say it in Java. Okay, that influence subsequent computation via the side effects of changing the value of memory. Okay, that's Von Neumann. Moving on, next type, a scripting. Okay, usually it is defined to be a subset of Von Neumann languages. Okay, they're distinguished by their emphasis on gluing together components that were originally developed as independent programs. Okay, so what do we have here? Of course, shell. Okay, bash, born again shell. Okay, PHP, JavaScript, of course. Okay. Technically, well, definitely Perl. Okay, technically Python is also a scripting language, but of course, it's a huge question. Maybe maybe it should be here. But okay, Python. What else? What else? Tickle. Okay, Tickle. Language used to describe the hardware. Ruby. Ruby. Okay. Okay. Most place emphasis on rapid prototyping with a bias towards ease of execution, ease of expression over speed of execution. Interesting, but all my friends who are in Google, they all tell me that Google use C++ a lot, C and C++. And it's interesting because I thought like Python would be the way to go, but no. Python, of course, is very easy to use, but it's much slower than C. And definitely also slower than C++. Okay. But originally, as far as I know, Python was developed as a language which is used to teach kids or like play kind of like games which would teach kids how to code. Okay, and then it just became so popular because again it's just so easy to use. So now it's like a very, very popular language. Python. Okay, moving on. Object-oriented. Oriented language. Yeah. So here I would say that Java. One human. Okay. Okay. Java should be here. Okay. Java is object-oriented programming language. Okay. Are related to one human languages. Okay, but have a much more structured and distributed model of both memory and computation. Okay, so rather than picture computation as the operation of monolithic processor on a monolithic memory, object-oriented languages picture it as interactions among semi-routines well no that's not routines hold on interactions among semi-independent objects each of which has both its own internal state and subroutines to manage that state. Okay. Okay, perfect. So here, of course, we have, so in C, by the way, C language example. I want to show you an example of how, like a code in C, what it looks like. You'll be surprised, but there are absolutely no classes. Okay, it's just like one piece of code where you have like the main method, and that's it. So it's impossible to have classes in C. Bubble sort, C programming example. Well, that's different. Anyway, so in C code, you don't have any objects. Okay, you just have the main method, and that's pretty much it. You don't even have any classes. Okay. Here though, in our favorite Java, C++, C Sharp, okay, you of course have everything. You definitely have those. Okay, cool, perfect. Okay, and I think what else for this one? No, that's it. That's it. Perfect. Okay, cool. So, and I think we'll call today here. So that's the first piece of information which you will need to remember for your exams. Okay, what kind of programming languages we have here. Okay, hope you guys enjoyed this. I'm hoping to see you next week. Okay, it's unlikely that I'll see you on Thursday. Have a good one. Bye bye.